We were discussing the chapter 5, that is the arithmetic progressions, and we'll try to see the sum of first n natural number. If you recall, the Shakila used to put 100 rupees in her daughter's money box when she was 1 year old. Then every year she adds up 50 rupees, that is, on her second birthday it became 150, then on the third birthday 200. So is there any way you can tell that how much money this money box will contain when her daughter is 21? So the first method is take 100, 150, 200 till 21st or 21 of these and then add it. Now this procedure seems to be quite tedious and time consuming. So is there any shorter method? Let us see. Gauss, famous mathematician, when he was 10 years old, he was given a problem. He was asked that you have to add 1 to 100 positive integers, and he immediately replied the sum is 50, 50, 5050. And can you guess how he actually arrived at this answer? He took it like this: s is equal to 1 plus 2 plus till 100. Then he reversed the numbers. Similarly, the same s will be their sum and this number will be reversed. We start from 100 until 1. He did that. Then he added both the equations, equation number 1 and equation number 2. So s plus s is 2s, 1 plus 100 is 100 plus 1, 2 plus 99 is 99 plus 2, and he saw that all these additions are 101, and he knew that these are how many times? 100 times. So he just multiplied 101 with 100, and because 2 was here, so he divided it with 2, so the answer came as 50-50. So in our discussion, we have seen that the AP was in the form of a plus d, a plus 2d. The sum can be written as a plus d, a plus 2d till a plus n minus 1 into d, which is our nth term. Now just reverse it the way Gauss did. A plus n minus 1 into d, you start with this and reach till a. The sum will remain same. So we have equation 1 and 2. Add these equations. So s plus s, that is 2s. So a plus n minus 1 into d, first one. Then a plus d, a plus n minus 2 into d. As we added, this becomes 2a plus n minus 1 into d, 2a plus n minus 1 into d. How many times? These are n times, right? They are n terms, so it will be n times. So just multiply this term, because they are individual and equal, and they are n times. So just multiply it by n. Now 2 is also here, so divide it by 2. And this exactly is the sum of n, the values or the list, which we call it as AP, arithmetic progression. So the sum of first n terms of an AP is nothing but n by 2, 2a plus n minus 1 into d. So you can also write it as a plus n minus 1 into d. This is what? This is the last term or the nth term. So a plus l also you can write if you are aware of or if you are given the last term. So this is how we got the easy answer to Shakila's problem. So let us solve her problem. She started with a equal to 100 rupees. She added 50 rupees every time, and at the end of 21 years, s will be n by 2, 2a plus n minus 1 into d, and that comes up to 12,600. So on her 21st birthday, Shakila's daughter will have 12,600. So we will write this s as s21, the subscript 21, showing it that the sum is till n equal to 21, or sum of first 21 list or the items in the list, which is we call it as AP. So s sum, a first element, d common difference, and n is the number of n's which the question will ask. Then let us come to the example. So find the sum of first 22 terms of the AP. 8, 3, minus 2, dot dot dot. So a is what? 8, Common difference is 3 minus 8, that is minus 5. And we have to find the sum of first 22 numbers, so n will be 22. Just place in this equation n by 2, 2a plus n minus 1 into d. These are known. The answer would come as 979 negative. If the sum of first 14 numbers or 14 terms of an AP is 1050, its first term is 10, find the 20th term. So the sum of 14 number is given. So we are being provided S14. So S14 would be 1050. This is equal to S14. This will be equal to n by 2, 2a plus n minus 1 into d. In this case, the first term is given as 10. So a will be 10. N is what? 14. And the sum is here. So 14 by 2, 2a plus n minus 1 into d. So d comes up to 10. Now we have to find what? We have to find the 20th term. So a20 will be equal to a plus 20 minus 1 into d. So a is known 10, d we just found out as 10, just place it here. 20 minus 1 is 19d, so the answer would be 200. How many terms of the AP 24 till must be taken so that their sum is 78? Now a is 24, d is 21 minus 24, that is minus 3. The Sn, which is the sum of these numbers, is 78. We need to find out how many numbers add up to 78. So Sn is 78, just place it here. We have to find out n, that will come to some quadratic equation. Just solve it by factorization, n minus 4, n minus 13, and will be 4 and 13. If you see the 4 term and 13 term, they both add to the same number. So this is the answer. Now you have to find the sum of the first 1000 positive integers. First 1000 positive integers, that is, you have to find out s equal to 1 plus 2 till 1000. Now the first term is given as 1, the last term is given as 1000. So you can directly apply Sn equal to, that is s 1000 is equal to n by 2 a plus l. A is 1, l plus 1000. So this comes to 1000 by 2 into 1001, that is equal to this 5,500,000. The Sn of the first these numbers, the question is like this: first n positive integers, so 1 to n. Now the answer will come in the form of n, in terms of n. First term is 1, last term is n. So we'll just directly use Sn is equal to n by 2 a plus l, that is 1 plus n, that is equal to n plus 1 by 2. Now this becomes very important because in later classes also we'll directly use the sum of first n numbers, positive integers or natural numbers. Why? Because this becomes very important, we'll directly use it. So please, you may memorize this. Now find the sum of first 24 terms of the list of numbers whose nth term is given by this. An is given, so let us take a1. You just have to place 1 here. a2, you place 2 here. a3, place 3 here. So 5, 7, 9. So this becomes a list. What is the first term? A, that is 5. Common difference is 7 minus 5, that is 7 minus 5, or 9 minus 7, 11 minus 9, that gives you 2. So common difference is 2. Now you have to find the sum of first 24 terms. So S24 you have to find. S24 will be n by 2, 2a plus n minus 1 into d. So n is 24. 2 into a, that is 2 into 5. n minus 1, 24 minus 1 into d. It gives you 672. Next is the manufacturer of TV sets produce 600 set in the third year. So A3 is given as 600. And we know we can directly write it as A plus 3 minus 1, that is 2D equal to 600. Similarly, the seventh year the production is 700. So A7, what is this? A plus 7 minus 1 into D, that is A plus 6D. So A plus 6D is what? 700. So A plus 6D is 700. A plus 2D is 600. Now we have to find various parts. So let us solve this. We can directly solve this. 6D minus 2, that is 4D, will be equal to 100. D will be equal to 25. And A is already given, that is 550. How did we come up? We can place this D in any of these equations, 1 or 2. And you can find out 550. So A and D we have found out using the situation which is given. Now the production in first year, the production in the 10th year, and the total production in the first 7 years. So the A10 will be A plus n minus 1 into D, that is 10 minus 1 into D. You know A and D, 775. S7, that is 7 by 2, because first 7 terms, 7 by 2, 2A plus 7 minus 1 into D, that is 4375. So the total production of TV sets in the first 7 years is 4375. So let us summarize what we have seen up till now. The arithmetic progression, they are nothing but the list of numbers which are obtained by adding constant D or equal D to the preceding number. We call this D as common difference. So if this is A, we add a D. Again A plus D, we add a D. A plus 2D, we add a D. So they differ by a common value which is called the common difference. And any nth term will be given by A plus n minus 1 into D. Then the sum of first n terms of an AP is given by S equal to n by 2, 2A plus n minus 1 into D. If you know the last term, sum will become n by 2 A plus L. A will be the first term, L will be the last term. So if you want to find out this B, and if A, B, C are in AP, you can directly find out B is equal to A plus C by 2. So this is all about the arithmetic progression. Thank you so much. Take care of yourself.